Good morning. Today we shift gears a little bit. We've been working on natural resources, but we've been focusing on mining, forestry up till now. And now we're going to switch into looking at mining. So you should have downloaded your notes at this point, so please make sure you have those with you. So what are minerals? A mineral is any natural, pure, non-living material found in the rocks of the earth. Minerals can be divided into three groups: metallic minerals, fossil fuels, and industrial minerals. So let's have a look at metallic minerals first. When metallic minerals are made pure, they become the metals we use every day. Metallic minerals need to have some quality that we value. They could be beautiful, like gold, silver. They could be very strong, like iron. They could conduct electricity, like copper. Or they could be both light and strong, like aluminum and tin. So there you've got some raw gold, some raw copper. Pardon me, that's the gold. I think that's silver. So you've got gold, you've got silver, you've got copper. Then we have fossil fuels. Fossil fuel is the leftover of biotic material. And so biotic material is material that used to be living material. Coal was one of the first important fossil fuels. It's actually the fuel that basically kept the Industrial Revolution going. But when coal is put under a lot of pressure, coal changes into diamonds, and we learned about this during the rock cycle. So this is a metamorphic rock when it becomes diamond. Oil and natural gas are now the most popular forms of fossil fuel. So we've kind of gotten rid of the coal, because coal is probably the dirtiest burning. When you burn coal, you're releasing carbon dioxide into the atmosphere. Fossil fuel mining requires oil rigs or other pumping mechanisms. And that is what we mean by a pumping mechanism. So you see these when you go to Alberta. If you've ever driven through Texas, you see a lot of these. And then, of course, they're the ones that are out in the ocean. They don't look quite like this, but you probably remember what some of those look like. And finally, there are industrial minerals. Industrial minerals are any mined minerals that are neither metallic nor fossil. So these are minerals mostly used by industries. So an example would be asbestos. Asbestos protects from fire and heat, although Canada has stopped production of asbestos because if you breathe in the small fibers of the asbestos, they lodge into your lungs and you end up with cancer. Then there's potash. Saskatchewan has got a lot of these. If you've ever driven through Saskatchewan and you see these weird conical shaped white hills, that's potash. They're storing potash there. And they use potash to make fertilizer. Then there's gypsum. We have a lot of that here in Manitoba, and we grind up that and we make it into drywall. And of course then there's diamond, and diamond is not just for jewelry. The small little tiny bits of diamond can be used as the edge of a cutting tool. So where do we find the minerals? Well, in Saskatchewan, there's the world's largest potash deposits. In Quebec, there are major asbestos mines, although the last one, if it hasn't already been shut down, it is soon to be shut down. Northwest Territories is where we have 3 diamond mines. That's actually our newest addition to our mining in Canada. We didn't discover those until the 1990s, I think it was. There are a ton of minerals in the Canadian Shield. You name it, they're there. You take a look at the mineral map that we did at the very beginning when we did the mapping part for what are natural resources. And there are a huge number of mines in the Canadian Shield. That's the area around the Hudson Bay. And of course, there's oil and gas in Alberta, although right now none of it's being shifted. So how important is mining? Canada is the third largest producer of minerals in the world, and only the United States and Russia are larger than us. We are, however, the largest exporter of minerals, the largest exporter of minerals. 80% of what we mine, we export. We don't do an awful lot of refining here in Canada, which is kind of too bad, because the more you process the minerals, the more valuable they become. Mining exports make up 18% of Canada's total exports. So we are still the hewers of wood and drawers of water. In other words, we are a storehouse for the rest of the world. And perhaps one of the things this pandemic is showing us is that now is probably a good time for us to start thinking about becoming a little bit more self-sufficient. In 2014, mining contributed $57 billion to our GDP. And because of mining, rail and road systems were developed because, of course, you've got to get to where the minerals are. So you've got to get to the remote and faraway deposits. So how do we find minerals? Mineral deposits that are economical to develop are called mineral reserves. So if somebody talks about a reserve, that doesn't mean that we're already mining it. It just means that it is economical to develop it. Metallic minerals are found in igneous and metamorphic rocks, like the ones that we have in the Canadian Shield. So if you have sedimentary rock, you are not going to find gold. In the earth, the minerals we want are mixed together with with other compounds like rocks and other minerals. And when you have all of this stuff mixed up together, we call it ore. A magnetometer creates a magnetic field which ore like nickel, iron, and copper react to. So if you've got your magnetometer out in an area and it starts reacting, one of these things is in that area. Satellite images and aerial photos give geologists clues. So when you become rich and famous geologists, you will know how to identify what kind of rocks, what kind of landforms you're looking for, and what that means in terms of the types of minerals that are underneath. Satellites can also be used to create thermal images, infrared images, and other imaging which various minerals react to. So depending on what filter you use, you get different minerals reacting and showing up. Once a potential site has been located, geologists will drill what's called a core sample. And what they do is they drill down and they take, it's like a big long column, and they'll pull it out and they'll take a look and see what's in it. And if there's enough, they'll drill another one, and then they'll drill another one until they get to the edge of the core, or of the ore body going this way. Then they'll do it again over here, over here, over here, and then in front, and then in behind, so that they get a really good picture of how big the ore body is. So using this method, they can locate the edges of the reserve. Okay, now I'm going to stop here because we're already almost at 10 minutes, and so I'm going to switch to another video. So up until this point, we have been focusing only on where minerals are and how we find minerals. Over the next few minutes, or in the next video, I'm going to be dealing with the different mining methods. Okay, so finish up your notes, and I'll see you back here right away.